Hello, dear students. Today we start with modern physics. At first we take the motion of electron in electric and magnetic fields. If the electron is moving with velocity v in presence of electric and magnetic fields, electric field E and magnetic field B, then the resultant force on the electron is called Lorentz force and is given by F is equal to electric force is E into E and magnetic force is BeV sin theta, where theta is the angle between magnetic field B and the velocity v of electron. And in vector notation, this can be written as F vector is equal to E is scalar, which is common to these, E times electric field vector E plus magnetic field vector B and velocity vector cross velocity vector V. Now we take some notes related to this. Number one is, if electric field E and magnetic field B are perpendicular to each other and theta is 90 degree, then electric force on electron is equal to magnetic force of electron, that is E into E will be equal to BeV, that is electric force is equal to magnetic force. This gives velocity v is equal to E upon B, and in this case both fields are called crossed fields, means the effect of one field is cancelled by the other field. Next, if E is 0 means electron is moving only in presence of magnetic field and theta is 90 degree, that is angle between the magnetic field and direction of motion of electron is 90 degree, then the electron moves in circular path such that centripetal force on electron becomes equal to the magnetic force on electron, that is BeV is equal to mv square upon r, which gives E upon m is equal to V upon rb, where r is the radius of circular path of electron and the ratio of charge to the mass of electron is known as specific charge of electron. We take some numerical problems related to the above formulas. First numerical is, an electron beam accelerated through a potential difference of 2000 volts enters uniform magnetic field of 0.02 Tesla at right angles. Find the radius of the circular path of electron in magnetic field. Mass of electron is given to be this much. Solution. Kinetic energy of accelerated electron is equal to the work done by the potential difference on electron. Therefore, E into V is equal to half mv square. Here V is the velocity and capital V is the potential difference, which gives V is equal to 2E capital V upon m square root, and putting the values, corresponding values, we get V is equal to under root 2E is electronic charge 1.6 10 to minus 19, B is 2000 volts and mass of electron is 9.1 into 10 to minus 31. On simplification we get velocity as 2.65 into 10 to power 7 meter per second. Now with this velocity, electrons enters perpendicular in the uniform magnetic field B of 0.02 Tesla at right angles. Therefore, BeV will be equal to centripetal force mv square upon r, which gives one velocity v cancels, and we get r is equal to, this v cancels, r is equal to mv upon b into e, and on putting the corresponding values we get r is equal to m 9.1 into 10 to minus 31, b is 2.65 10 to power 7 upon b 0.02 magnetic field, and E is electronic charge 1.6 into 10 to minus 19. On simplification, we get the radius as 0.0075 meter. 0.0075 meter. Second problem is, specific charge on a particle is 4.4 into 10 to power 7 coulomb per kg. The particle is moving with velocity 3.52 into 10 to power 5 meter per second at right angles to the magnetic field of 0.4 Tesla. Find the radius of the orbit. Now, solution. Here, specific charge means Q upon m. If Q is the charge on electron and m is its mass, then its specific charge. Of particle is given to be 4.4 into 10 to power 7 coulomb per kg, and it is moving at right angles to magnetic field of 0.4 Tesla with velocity 3.52 into 10 to power 5 meter per second. Theta is 90 degree and magnetic field is 0.4 Tesla. We have to find the radius. Now, if the particle has charge Q, then magnetic field will be BQV, which is mv square upon r. This gives r is equal to mv upon bq, and it can be written as b upon b times q upon m. Now, b and q by m are known, so you can calculate this as 3.52 into 10 to the power 5 upon magnetic field 0.4 Tesla, specific charge 4.4 into 10 to the power 7, and on simplification we get the radius as 0.02 meter. Next numerical is, a beam of electrons is under a potential difference of 1.36 into 10 to the power 4 volts applied across two parallel plates which are 4 cm apart, and a magnetic field of 2 into 10 to minus 3 Tesla at right angles to each other. Means electric and magnetic fields are perpendicular to each other. If the electron beam is not deflected, then calculate velocity of electrons and radius of electron orbit if electric field is made 0. Now, we come to the solution. As the electron beam is not deflected under the effect of electric and magnetic fields, acting together perpendicular to each other, then the two fields will be crossed fields, and in that case electric force and magnetic force on electron will be same for the crossed fields. Magnetic force BV is equal to electric force E into E, which gives V as E upon B, and as you know, E is equal to potential gradient means V by D. So E can be replaced as V by capital V by D upon B. Here V is given to be 1.36 into 10 to power 4 and D is 4 cm. 4 cm means 0.04 meter upon B is 2 into 10 to power minus 3 Tesla. On simplification, we get the velocity of electron as 1.7 into 10 to power 1.7 into 10 to power 7 meter per second. Now, second part. When the electric field is made zero, then the electron moves in perpendicular magnetic field. Therefore, B will be equal to, when E becomes 0, then B will be equal to mv square upon R, which gives R as mv upon B into E, and on putting the corresponding values we get 9.1 into 10 to minus 31. B is 1.7 into 10 to power 7 upon B is 2 into 10 to minus 3 and E is 1.6 into 10 to minus 19. On simplification, we get the radius as 0.048 meter.